In today's video, I'll be introducing you to matrices. Right, so what is a matrix? A matrix is just an ordered rectangular arrangement of real numbers into m rows and n columns. What do we mean by that? Let's say we have a matrix A, and if we are to order it into a rectangular arrangement of m rows and n columns, we would have something like this. For example, 1, 2, 3, 4. Right? So we have how many rows? We have 2 rows, and we also have 2 columns. So this is what we call a 2 by 2 matrix. Or we can also have B, which is 1, 2, 3, 4, 5, 6, 7, 8. So this is a 2 by 4 matrix because it has 2 rows and 4 columns. So a matrix is just an ordered rectangular arrangement of real numbers into m rows and into n columns. So what does this mean in definition? So in definition, we say A is defined by a matrix. Remember that we have these square brackets to show that something is a matrix with these entries A11, A12, A1n. Let me just quickly write this down. Right, so in definition, this means that we have this matrix A with entries in first row, first column, first row, second column. These subscripts just mean rows and column. The I and J, they're represented by the I and J. So it can also be represented by Aij, M by N. This means it's an M by N matrix with entries at I's column and J's column, where the entry itself can be a real number. What do we mean by this? It means that this position can be any real number, and as well as this position can be any real number. It can be a -1, it can be a 0, it can be a half. Any real number can occupy this position. This is the same as this position because Ij is represented by 1 in this case. So Aij, the entry itself, is an element of all real numbers. So these are elements, all these are elements, and this is an M by N matrix, right? So now, when are two matrices equal? When do we say that these two matrices are equal? For example, let's say we have matrix A, where we denote its entries as Aij, and matrix B, and in this case we're going to say Bij as well. When will we say that A and B are actually equal matrices, right? So we say A and B will only be equal only if they are of the same size and if entries in corresponding positions are equal. What do we mean by that? So in other words, Aij should be equal to Bij for all real numbers, right? So Aij should be equal to Bij for all real numbers. Let's say we have A being equal to, let's say 1, 2, 3, 4, and we have B as matrix 1, 2, 4, 3. These two are of the same size because they are 2 by 2 matrices, right? So this is 2 by 2, 2 by 2. First condition is met, but the entries 1, 1, 2, 2, 3, and 4. 3 and 4 are not equal, although they are corresponding. So the corresponding entries, these ones, need to be equal, just like 1 and 1, right? And 2 and 2 in this case, because they are corresponding and they are also equal. But 3 and 4, they are corresponding in position, but they are not equal. And 4 and 3, they are corresponding in position, but they are not equal. So this means that A is not equal to B, right? So Aij should be equal to Bij for all real numbers. So all entries in this matrix should be equal to all entries in this matrix in corresponding positions, and they should also have the same size. If it's 2 by 2, this one also has to be 2 by 2. If it's 3 by 3, this one also has to be 3 by 3 with same corresponding entries. Finally, in this video, we'll be talking about the types of matrices. There are different types of matrices, and the first type of a matrix is what we call a square matrix. So what is a square matrix? A square matrix is a matrix with rows being equal to columns. So we've seen this before. An example of a square matrix is what we've done already. So for example, A being equal to 1, 2, 3, 4, right? So this is a 2 by 2, which means the n is equal to m in this case. So it's just an n by n matrix. So this is a square matrix because the rows are equal to columns. Number 2, we have a zero matrix. A zero matrix is a matrix where all the entries are zero. For example, A being equal to all zeros. Alright, so this is a zero matrix. A row matrix is a matrix with only one row. Now let's do another example again. With only one row, it can be just your numbers. For example, 1, 2, 3, 4. You only have one row and 4 columns, which means it's a 1 by 4 matrix. Same as column matrix. A column matrix, it's in the name. It's a matrix with only one column. For example, let's say B, one column, 1, 2, 3, 4, 5. This is a 5 by 1 matrix. And then on number 5, we have a diagonal matrix. A diagonal matrix is a square matrix. So that's the first condition. It should be a square matrix, which means it's n by n. That has entries of 0 everywhere except the main diagonal. So it is a square matrix. That's the first condition. And it has entries of zeros everywhere except the main diagonal. What do I mean by this? First, let's have a matrix. Let's first establish what a main diagonal is. So first of all, if it's a square matrix, we know that it should be a n by n. In this case, let's work with a 3 by 3, right? So the main diagonal is the diagonal from left to right. So let's say 1, 2, 3. Every entry except in the main diagonal should be 0. So this is a diagonal matrix. So zeros everywhere except the main diagonal. This is your main diagonal. So that's your diagonal matrix. Number 6, we have an identity matrix denoted by IN. The identity matrix as well should be a square matrix, which means it's n by n, and where in the main diagonal we have only ones and everything else is 0. So it's similar to a diagonal matrix. It's just that in the main diagonal we no longer have random numbers, we now have ones. So in other words, let's try it again. We have ones in the main diagonal and we have zeros everywhere. So just like that. This is not a 6, by the way. This is a 0. So this is a 3 by 3 identity matrix, which means we can also write I3 is equal to this identity matrix. Number 7, we have a symmetric matrix. It's a square matrix where the entries of the upper and lower are reflected about the main diagonal. What do we mean by this? In other words, by definition, we say Aij should be equal to Aji. So it should be symmetric about the main diagonal. If we were to give an example, we would have a matrix like this. So as an example, we have this matrix, right? So remember that this is A11. A11 is the same as A11 because we were just swapping rows and columns. So if your I and J are 11, your J and I will also be 11, right? So in other words, A12 should be equal to A21. What is our A21? Our A12, our A12 is -1 and our A21 is -1. So this is the same as this. Remember that this is our main diagonal. This is our main diagonal. And in other words, A13 should be equal to A31. What is our A31? Our A31 is this. And our 813 is this, and our 831 is 5. So you see it's a reflection about the main diagonal, and our A23 is a 3 and our A32 is a 3, just like that. So that's what we call a symmetric matrix. Aij should be equal to Aji. And then finally but not least, we'll be talking about triangular matrices. Right, so there are two kinds of triangular matrices. There's upper and there's lower. An upper matrix has zeros below the main diagonal and entries of non-zero above the main diagonal. So for example, let's say we have this matrix. So this is upper matrix because below the main diagonal we have only zeros, but above this, we have a triangle with entries that are non-zero, right? So this is an upper triangular matrix. And as you can guess, the lower triangular matrix is we have zeros at the top, and then we have non-zero entries at the bottom. So we have something like this. So the lower triangular matrix, we have zeros at the top, and we have non-zero entries below the main diagonal, right? So these two are called triangular matrices. This is it from me. I hope this video was valuable, and if you found value in this video, please consider liking and subscribing. I will see you in the next video.